We are on lesson 5. We're going to graph systems of inequalities. Remember, we did that in our last unit. I like to do this with 2 different color writing utensils. I will do one line in one color. I will do the other line in a different color. Completely up to you. It just helps me see clearly. I'm going to graph this equation. I would start at plus 2. My slope is 2, so positive 2 means up to right 1, up to right 1. Again, get your little straight edge out. Now, let's think back. This is not an equal to sign, so I know that I need to use a dashed line. So I'm going to try to make it very obvious that I have a dashed line. Putting my pencil on the y-intercept, I need all y's less than that, so I'm going to lightly shade below because below this point is where my y's are less. Now, I need to graph the second equation that starts at -3, so 1, 2, 3. That's just a negative sign. We know that that means -1, so I'll move down 1, right 1, down 1, right 1, and so forth. This is greater than or equal to, so please remember we need to have a solid line, so I'm going to make it nice and solid. Putting my pencil on the y-intercept, I need all the y's that are greater than that, so I need to shade above the line. In the area where I will have my purple and my green is where I will find ordered pairs or points on the graph that will work on both math problems. If I pick an ordered pair, if I pick the point 0, 0, for example, if I put 0 in, is that a true statement? Yes, 0 is less than 2. If I put 0 into this equation, we know that 0 is greater than -3. It is true in that equation. So anywhere the highlighted area is, or the purple and the green overlap, I will have solutions that work in both. Okay, as you know, I prefer to graph things in slope-intercept form, so I'm going to rewrite that carefully. I would subtract 2 x's from both sides. Start at 4, 1, 2, 3, 4. My slope is -2, so I move down to right 1, down to right 1. Then I'm going to ask myself and pay very close attention to the sign. Would I have a solid or a dashed line? This one would be solid, so I'm going to make it nice and solid. Putting my pen at the y-intercept, I need all y's less than that, so I would shade below because if this is 4, that's 3 and 0, etc. Okay, I'm going to rewrite this into slope-intercept form. Divide by 2. I am leaving, this is a fraction, so I have a rise over a run. My starting point for this one will be at a half. I don't really like that, but that is what it is. And then I move up 5, so 1, 2, 3, 4, 5, right 2. I can only fit, I could go down 1, 2, 3, 4, 5, left 2. This is only less than, so I need to have a dashed line. So I'm going to make it very obvious that my line is dashed. Putting my pencil at the y-intercept, I need all y's less than that. That would be to the right of my dash line. And I can see right here the red and the purple lines overlap. So again, any ordered pair from here will work in both equations. I need to turn the page. Okay, pick your two colors. Doesn't matter to me which ones you pick. I am going to switch this to slope-intercept form. I start at +4, 1, 2, 3, 4. Move down to right 1, down to right 1. I have a greater than or equal to, so I need to have a solid line. In a different color, I'm going to graph this one. I start at -1, and I will move down to right 1, down to right 1. I am going, oops, I forgot to shade. My apologies. Go back to my green line a minute. Put your pencil or your pen here. I need y's greater than this, so I would shade above. Okay, my apologies. Now, this is just less than, not equal to, so I need a dashed line. I'm going to try to make it obvious that it is dashed. Putting my pencil on the y-intercept, I need all y's less than that. They would be below. Oh, what I notice, again, if we look here, we have the same slope. So we kind of knew they were going to be parallel. In this case, they shaded on opposite sides of each other. So there is absolutely no solution that they will have in common. Okay, moving to the next one. Remember, you can add 0 to any math problem in the world, and it will never change. So I start at the origin. There is one invisible x here, so I'm going to move up 1, right 1. It can be less than or equal to, so I need to have a solid line. Putting my pen at the y-intercept, I need y's less, so I will shade below. This one, I begin at -3, 1, 2, 3. I have a slope of 1 again, so up 1, right 1. Ooh, that seems familiar to me. We have the same slopes. I'm anticipating parallel, dashed line. So I'm trying to make it very obvious. I need all y's greater than this pencil, so I'm going to shade above. This time, compared to the one right next to it, in between the two parallel lines, I notice both blue and orange ink marks, so any of those ordered pairs in between the two lines would work on both equations. I would like you to pause the video. The bottom one has 3 equations. You're going to put them all on one graph. Take your time. I would like to compare our pictures when we are done. Please pause the video. Thank you for pausing the video. In purple, which is kind of hard to see here, I graphed the line. Y is greater than -2. It's a solid line, left and right, horizontal, shading above. In green, I rewrote this into slope-intercept form. Started at 1, up 1, right 1, dashed line, shading below, so that I ended with the yellow little triangle area. This one, I just graphed the lines. I did not do the shading yet. For this, I have in red. I rewrote that. Notice we had to divide by a -2, so I flipped the inequality sign. If my pen is here and I need all y's greater than, I would have to shade above the line. This is very hard to see, but there is actually a green line, solid, where x is -2. I need all x's greater than that, so I am going to shade on the right. And then my purpley color, I rewrote the equation, subtracted 3x's divided by 4. It got me that solid line. There I need all y's that are less than that, so I'm going to shade below. And in this colorful hot mess, you will find in the center here in this triangle is where you will see my three colors, the red, the green, and the purple.